Hi, I'm Mingru from Shenzhen University. I'm going to present our work, Layer Image Vectorization View Semantic Simplification. So image vectorization is given a raster image and try to construct the visual vector graphics from it. There are groups of related work, such as based on meshes, polyline or polygon fitting, or nowadays some deep-based learning method. So for this image vectorization method, there are basically two goals. The first one is to achieve high visual fidelity, that is try to reconstruct the image as accurate as possible. Another is to maintain structural representations between those vector primitives, such as layers. Our approach is try to solve this image vectorization problem. That is, given a target image, we try to generate the vector which is with high visual fidelity to the original one. And also, our vector primitives are organized in layered structures such as from the coarse to fine granularity. And for the shapes of the vector primitives, we try to maintain its semantic. So the basic idea of our work is first to generate a sequence of simplified image. Then with this image, we construct the vectors from the most simplified to the original one to get the output vectors. Specifically, give the target image, we propose SDS-based image simplifications to generate a sequence of simplified image. Then we applied semantic segmentation and layering to get its masks. And based on these masks, we construct layered structural vectors to get the structure-wise vector. And with this structure vector, we do color fitting to fit it to the target image. And then we refined the visual appearance by generate some visual primitives there. So we utilize the feature average effect in SDS. In a general SDS image model, that as the optimized steps increase, the image becomes blurred and the feature averaged. That is because the SDS update direction is pretty sensitive to input texture condition. That is that given the image, it can be updated into different directions. Say here, 3 different appearance of those cars. Then we average those cars to get the image. But in this image, the individual characters are averaged and blurred. So that is the feature average effect. But as we see here, the general SDS will cause significant shape change. So we refine this by utilizing the classifier-free guidance. The basic idea is to turn off the conditional prediction noise by setting the CFG scale to 0 or setting the texture prompt to empty string, so the structure can be maintained better. Here shows one more sequence of the simplified image. And as we see with the simplified mask, we can get the whole mask for the whole lobed, which is not in the original target image. With those masks, we applied the structure-wise construction and visual-wise refinement under the framework of differentiable rendering. Here shows the process of the vector construction. We compared our method to full state-of-the-art in terms of visual fidelity, layered representations, and semantic alignment. Please refer to our paper and project homepage. Our code has been open sourced. Thank you.